Okay, let us begin. The problem asks you to find out admissible B to the problem. Yeah. So as the problem suggests to you, you need to augment the matrix first and then do the Gaussian elimination on it. So this will be the augmented matrix 1, 2, 3, B1, 2, 4, 6, minus 2, 1, 5, and this one 7, 4, 10, 4. Okay. The easy step is to row 2 minus 2 row 1. Okay, this row 2 minus 2 row 1. What else? Row 3 plus 2 row 1. Yeah, plus. And then row 4 minus 7 row 1. So you will have the new matrix to be 1, 2, 3. The first row no change, and in here all 0. And this one B2 minus B1. Of course, this will be the answer, yeah. The relationship. But we cannot stop here. 1 plus 2 is 5. 5 plus 2, this is 11. And here 4 minus, that's minus 10. 10 minus, that's minus 11. In here, this is B3 plus 2B1. B4 minus 7B1. Yeah, okay. Yeah, actually, you don't really have to switch the rows in this case. Switching the rows for row 2 and row 3, 4, it is not necessary. Yeah, it is optional. You can do it, or you stay with it. It is okay. Okay, but the main thing is don't stop here. Why? Because later on when you eliminate this, there is a possibility that this row will also be all 0 here. If that's the case, then this is not the only condition. Okay, let's say we do one more time Gaussian elimination for the third and the fourth row, and then you find out the third and the fourth become all 0, then all of them is dependent on each other. Okay, yeah, the quiz problem is telling you the hint, right? B3, B4 are free to choose, and B2, B1 dependent on each other. So this will be the answer, but we still have to reduce it again. So I will opt to stay with it. I will not change the row, no change row. And then what I will do is row 3. No. So I will just row 4, yeah. Row 4.
Oh yeah, row 4 aja.
We can either eliminate row 3 or row 4. That's the same. Okay. I can do row 3. 2 row 3 plus row 4. Okay. I can do this. 2 row 3 plus row 4. And then I have 1, 2, 3, B1. This is still 0. Okay, and then this is 0, 0. How much is this? 22 minus 11. That's 11 again. 0 minus 10 and minus 11. Oh yeah, okay. 2 row 3. This is 2 B3 plus 2 B1 plus B4 minus 7B1, and this is still B4 minus 7B1. Okay, so we arrive here, and then this one cannot be reduced more. Yeah, you see, row number 4 we cannot reduce it more. Okay, this is the limit. We cannot reduce it anymore. Correct. Also, row 3 we cannot reduce it anymore. So this is the last step. For the rows that are non-zero, not all zero, yeah. This is non-zero rows, non-zero rows, non-zero rows. That means these are free to choose. Actually, B1, B3, B4, you're free to choose. But you can see, because this is all zero, then this will be the condition for the solvability. Yeah, admissible B you find out from here. So that means finally the B will be, this is B1, and then this is 2B1, B3, B4. Okay. Yeah, B1 free to choose, B2 dependent on it, or you can flip them. Okay. Yeah, B2 free to choose, but B1 has to be half of the B2. Yeah, B3, B4 are free to choose. Alfred.
At the end of the day, the row 3 and row 4 is not. No, will be not.
Yeah.
Why do you
Now we don't know, right? If at the end of the day, so before the end of the day, do you know? That's the thing, right? You have to check. Yeah, how do you know? You have to prove. Prove it. wait, we haven't finished.
Okay.
You're okay, right? One way to prove it is that you reduce it like this using Gaussian elimination. If you cannot reduce it furthermore, then that's the limit. It is linear independence in a way. Or you can opt to select a constant. Yeah, find out whether these two rows are linear independent or not. Okay, you still have to reduce it. I cannot. We cannot. Yeah.
Kalau ngambil 10 jadi 5 bukan 5 boleh.
Yes. It is also possible.
Then the B3 itu harus tulis B3 ya.
Which one?
Kalau tulis yang B1 to B1 B4.
This one?
Yang B4.
Yeah. This is still B3 and B4.
Oh, kalau tulis equation salah ya.
It will be only different in this.
Nah, B3 B4 itu.
No. You are not writing B3 and B4 in here. You are writing in here the final answer. Okay, I will give you the second choice, yeah, second option.
But I'm not
You write the final answer.
Yeah,
Question
question.
one, and then
or the B3 and B4 I tulis.
Oh, that's wrong.
Mana sih?
This is not the final B3 and B4. No.
Oh,
Yes, that's wrong.
aku agak bingung. Makanya kalau kita pakai Gaussian harus bikin upper triangle. Kalau kita bikin kayak gini,
No, upper triangular is just to guide you that you eliminate the bottom row by using the top row. Okay. But if I know what I'm doing, I can eliminate the top row using the bottom row. I can do that.
so what it's supposed to look like, sir? Is
It's supposed to look like a linear independence row in this case. Now in this format, we know that this and this row are linear independent. Okay? This one and that one also linear independent. This one and that one also linear independent. Okay, in this format now we know clearly they are linear independent. So
So it doesn't have to be.
actually it doesn't have to be upper triangle. It is just to guide us. Okay.
Oh,
Yes.
the final writing format. Of course, so bad. Is it okay to write 2-1?
No, you have to write like this.
itu gitu juga.
Yeah, it's wrong. It's wrong.
Cuma B2-nya aja yang diganti.
If you write down like this, then B4 has to be related to the 7B1. Do you know why we write down this? Now, what's the reason why we put B2 equal to 2B1? What's the reason? What's the reason? From this, what do you read?
So there will be solution.
Okay, let me read here, yeah. Well, let's read the second row, yeah. 0 times x1 plus 0 times x2 plus 0 times x3 must be equal to this one. Okay, let me write down here, yeah. 0 x1, 0 x2 plus 0 x3 equal to B2 minus B1 minus 2B1. So these are all 0. 0, right? 0 times x1, 0 x2, 0 x3. This is 0, right? Agree with me?
Yeah.
So 0 is equal to B2 minus 2B1. So this has to hold, which is why B2 is equal to 2B1. Okay. Now you ask me, can I put this here? What's the equation say? It is 0 times x1 plus 0 x2 plus 11 x3 equal to plus 2b1. Nah, cannot, right? Do you want to put 0 here?
Final answer-nya lu gak tahu.
Okay, now you know what is wrong. Why? Okay.
Equation-nya bukan.
Yeah.
You write it as
Equation-nya salah.
you substitute the B1 instead of B2.
You can.
That is legal.
That's legal. You write down, just now I said it. In here, half B2, B2, B3, B4. You can also do this.
Gue jawaban tadi 2B atau min ya?
But if you put this, that this is wrong. Because this is not 0. Okay. Okay, you want everything to be 0, so your grade is 0 also, right?
Wah.
Yeah, you want everything to be 0.
5.
Okay, let's move on to the next problem.
Satu doang. Ya ada
Next problem here, we have vector P.
Ya bisa yang gue kirim sekalian.
And then U1 and U2 are orthonormal. I'm saying here orthonormal, yeah. What does it mean by orthonormal?
Times the product itself is 1 times other normal.
Okay, they are orthogonal, linear independent, and also okay, UI transpose UI is equal to 1, and then what? UI UJ 0. Okay, you multiply with different vector, you get 0. Yeah, dot product with different vector is 0. Yeah. Now, what property that you use to answer that any vector P can be expressed uniquely? Huh? No. Now, express uniquely. We can express any vector P uniquely. Unique. Do you know what unique? Let's say you have a vector P. Let's say this is 1 and 5, okay? Because U1, U2 are orthonormal, you will not find different C1, C2 to get this. Let's say the first C1 is 5, the first C2 is -3. You get this. And then you find out another C1 equal to 10, C2 equal to 2. You get this. That's not possible. Okay, this is what it means by unique. You get what I mean?
Yeah.
Okay. So I cannot have two sets of C1, C2 to obtain one similar P. I cannot do that because this is unique. Okay. So what is the property that I can use to explain? I can express this uniquely. Yeah, this one. Okay. And then one more, because these vector are linear independent. And then one more. Yep, this one forms the basis for R2. Okay. Because U1, U2 form a basis for R2, then you can get any vector P uniquely using the linear combination. So that means this linear combination span R2. Okay, that's the requirement. Okay. If the linear combination span R2, then you can get any vector from the linear combination. Uniquely is that what? Not the same span. It is span R2. Span R2 and they are linear independent. Or you can answer it forms a basis for R2. Okay, the answer is that the first one, U1, U2, linear independent. Okay, the second one is that U1, U2, span R2. That's the answer. If it is R3, okay, then you need the U3. Okay. What if I have up to Cn, Un in there? Span Rn. Okay, span Rn. Yeah, this is what we discuss all of the time in chapter 7. Span, basis, linear independent. Okay. If these are not linear independent, then you can get one vector by using two separated different set of C1, C2. You can get that. Okay. Okay, that's about the expressing it uniquely. What about deriving constant C1 and C2?
The total
Yeah, we will use this, yeah.
Kalau nggak pakai transpose,
aku pakai transpose.
kalau nggak pakai transpose,
Yes.
Udah salah berarti.
salah berarti.
Salah total.
Minus 1 poin.
Lu tadi terus pakai transpose gak, Wi? Lu terus pakai transpose gak?
Enggak juga.
Kafe.
Nah,
Ya udah salah berarti.
Salah juga semua.
Yuk kali.
Yeah, writing that,
Tadi
can you multiply this? Okay, multiply this. What's the result? It is a vector, you multiply this. What do you have? Yeah, you cannot. If you say this one, then it becomes,
Wah, udah. Oh, tadi malam kena truk guys.
Nah, itu bisa.
this one can.
Bro.
So there is no this, that's wrong.
Oh, udah salah. Salah.
Yes, of course.
Enggak ada.
Just one letter could have saved it. One letter could have saved it. Solid banget.
Kami feel together dong.
Nomor 1 udah salah, nomor 2 udah salah.
Solid, bro.
Nomor 3 kalau A gue salah udah habis udah.
Okay, if I multiply vector v from the left, I'm using U1 transpose, multiply by that. Then this one also from the left, I have to multiply, yeah?
Tadi gue bilang C1 equals C1 U1 times U1 transpose
Okay, yeah, you will have U1 transpose P equal to
U1 times U1 transpose
U1 transpose U1 plus
itu U1 transpose U2.
okay, then what is this?
C1 is equals to 1.
U1 and this one?
It is equals to 0.
0. Okay. So this will be the C1. You write this but without transpose?
Yes.
Yes. Of course, that's a mistake. Yeah. Imagine you are writing a code, submit to MATLAB, MATLAB will not run your code. Yeah. Yeah, this is the error code now. We run your code now, and this is the error code. If we multiply by U2, then you will get the C2, okay? Ah,
Ya bu.
C1. Okay, that's for C2.
Udah berapa kali gitu udah percaya.
Any question on that?
Ya pasti jelas tahu.
Beda bro. Ujiannya lebih ribet.
Sama.
Gue 2 poin bro.
Konsepnya masih sama.
Yeah, the quiz is
Bro, soal satu.
just like kisi-kisi, ya.
Hampir salah bro, namanya sama persis.
You have more than enough information already, yeah, for the exam, for the quiz. You have more than enough information for the exam and also the quiz. What? Yes, but harder. What?
Kalau soalnya kayak nomor 1 lagi gimana?
I stated
Ada
every
5,
single class. I stated that the exam will be 3 problems. How many times I have to repeat that?
3 more times.
The exam is 3 problems. The exam 2 has 3 problems. The exam 3 has 3 problems.
I'll remember that. Thank you, sir.
Problem anak-anak ada pasti.
Dulu biar pasti jelas.
Baik anak-anaknya bro. Pokoknya
Lebih baik salah sekali.
Okay. Problem number 3.
Gak salah baca kan.
Right. If you write down in a matrix form, x dot. Okay. You will know that it is coupled. Okay. So it is clearer whether it is coupled or not after you write down the matrix form. Yeah. And what Raffi said just now is because of the anti-diagonal is non-zero. Then it is coupled. Yeah. What's your explanation? No.
Om yang dependent yang X1 sama X2
Aku turunin eigenvalue terus karena nggak bisa dipisahin artinya teknik kan sama cuman nggak
bisa dipisahin bro.
What does it mean?
kan X1 X2 kan nggak bisa
Sir,
dipisahin
kalau dibilang dependent to each other nggak bisa, jadi salah gitu.
What?
Dependent. Karena ada X1 X2.
In what sense it is dependent?
The equation.
Setiap variable, sir.
Iya, ada X1 X2 di equation.
I don't understand.
Kalau salah masih dapat nilai nggak sih atau langsung
Zero.
Ya, zero lah.
salah berarti.
Kalau
gampang banget
Ya. Ya.
kan 3A sama 3B sih beda. 3A
Yeah.
kan the whole number of 3 right?
Yeah, 3A is zero.
Not the whole number.
Not the whole number.
San, jangan pasang trap gitu dong, San. Pas lagi kerja langsung gemetar gitu.
Okay, now eigenvalue of A. And now we have V1, V2 equal to lambda V1, V2. Yep. The first eigenvalue clearly 0. How do we know that? Yeah, there is a solution to this, yeah. There is a solution to this. If you find a solution to this, then 0 is an eigenvalue to it. Or if you find that this row is not linear independent, the column not linear independent, then 0 is an eigenvalue. This column is just minus 1 times this column, right? Yeah, so they are not independent. We know 0 is the first eigenvalue, and then the eigenvector is?
-1.
Yeah, 1 and 1, correct. Okay, so the first eigenvector is 4, 1, 1, 1. Clearly.
Don't forget that. Gue gak lupa alfanya sebenarnya.
And then if you want,
Apa ya gue gak lupa.
Pasti salah ya.
yeah, let us get the second eigenvalue. So we write down A minus lambda I.
Tapi kok jadi satu semua?
1,
Nah, udah bilang kan. Lawa. Lain kali tulis di
okay,
buku.
then the determinant of this so it will be we can take out the minus, yeah, take out the minus.
Iya.
So it will be minus 1 plus lambda, and then multiply by minus of 1 plus lambda, and then this is minus 1. Yeah, so it will be just 1 plus lambda squared.
Iya.
Okay, 1 plus lambda square minus 1. Okay, this is equal to 0. Yeah, this is minus 1, right? This is minus 1. So I just want to write down here that without having to expand the roots, we can get the answer. We can get the answer. 1 plus lambda square minus 1 equals to 0. Yeah, 0 is an eigenvalue because when we put lambda equal to 0, this will be 0, yeah? Okay. And then, because this is minus 1, then we only need this to be 1 or minus 1. Okay. 1 plus lambda equal to 1 is when lambda is equal to 0. Okay. And 1 plus lambda equal to 1 is when lambda is equal to minus 2. Sorry, this is minus 1. So 1 square, you get 1. 1 minus 1, 0. Minus 1, you square it, get 1. 1 minus 1, 0. So,
Plus minus.
so this is the eigenvalue. Eigenvector, we know it already, yeah? For lambda equal to 0. And then for lambda equal to minus 2, the eigenvector will be minus 1 plus 2. In here, 1, V1, 2. Okay. So what do we have? Minus 1 plus 2?
1,
1. Okay.
1, 1, 1, 1.
V1 plus V2 equal to 0. So that means
1
Goes to minus
is minus V2. Then the second eigenvector will be alpha 2, 1 minus 1.
I did not.
Okay. So that's the answer for number B.
Kalau aku tuh di situ alpha 1, alpha 1.
Yeah, alpha 1 is used here, right?
If I put it there, it's good.
Yes, wrong. That's wrong. It's super bit different. Yes, different. Also wrong. Yeah. So for the eigenvector, you need to put the alpha.
Oke.
Ya.
Gue taruh alfa cuma alfanya salah. Gue pikir boleh salah.
Lagi.
Ya, ya.
Salah lagi. Teorinya kan alpha 1 equals alpha 2. Where alpha 1 and 2 is real number gitu kan.
Where?
Hah?
In what place?
Alpha 1 and alpha 2 are all real number.
Yeah, real number. But they are not the same.
Sama bro. All real number.
Yeah, all real number, but they don't put them as the same.
Wah, alfa 1.
If you are writing just a value 1 and minus 1, yeah, it only
Terus alfanya salah.
shows a point, not a direction. Okay, just a point. Okay, which is why you have to put this. Then it gives you a direction.
Ya, salah dikit lah.
Either this
Question?
No, I believe V2 is equal to x1, x2 is equal to lambda gitu. Di tengah-tengahnya ada x1, x2.
What is x1, x2?
Gue bakal turun.
Itu kalau terus nggak apa-apa. Enggak dong.
The last one, C1, V1, E lambda 1t.
aja kan baru cek.
Itu benar kan? Lu lambda yang benar kan?
Okay.
Gue bikin lambda ya semua lambda sama.
Baru cek.
Then if you want to put the solution, if I put all of the solution, then it becomes C1, and this is alpha 1 times 1 1
Lagi bro.
e to the power of 0
Iya,
1 plus C2, this is alpha 2 e minus 2 t. Okay.
The alpha 1
Ya.
atau eigenvector solid direction so what?
It is a direction, so that means the C1, it can be absorbed into the alpha 1 itself in this case. Yeah. So we can regard this as
Tapi gue terus alpha 1.
C1 bar, let's say. Yeah, in this situation, you can either write C1 bar or just C1, because alpha and C1 are both real number.
Ini kita bisa cari C1, C2-nya juga ya, San?
Yes, of course.
Oh, habis ini. Oh, harus ada
If you
dua.
put the bar or not, that's okay. Okay, because the alpha 1 is absorbed into the C1
Oh,
itself.
jadi kalau kita tulis yang the
Yeah.
one is okay. Oh,
So if you write down here without the alpha 1, that's fine.
Tapi masih ada bar.
No need the bar. I said just now, with or without the bar is okay.
oh, ini doang ini.
Okay. So whether you write this,
San kamu.
okay, I will write three flavors. Okay.
Kalau gue gak bisa nerima gitu, dan saya nggak ini ya, sorry.
C1,
Bilang ini salah di paling akhir.
okay. If you write like this is okay. Yeah. When you write down like this is okay. Why is that so? The reason is that alpha is absorbed into the C1. Alpha 2 absorbed into the C2. Okay. So how do we find the answer? C1 and C2? Okay, when we put the initial condition, yeah, after this we will be done. Yeah, some more minutes. So it says that x0 is 0 and 1, yeah, correct? X0 is 0 and 1. X1 0 is 0, x2 0 is 1. So this will be C1 plus this is C2 and minus C2. Okay. If I put t equal to 0, this will be 1. Yeah? Okay. Agree? So after that, you will find out that C1 is equal to minus C2. Oh, this is C1. From the first equation, you will get C1 equal to minus C2. Yeah. Okay. And then the second equation says 1 is equal to C1 minus C2. Then substitute this. 1 is equal to minus C2 minus C2. Yeah, and then you get 1 is equal to minus 2C2 minus half.
Tahu. Satu yang setengah.
And then C1 is just half. Yeah. Okay, why are you laughing? Wrong, is it? How come? C2 is 0.
I don't know. Still remembering what I'm good.
Udah, tunggu aja nanti hasilnya.
Okay, any question on this? So on the exam 2, you will be asked to find out C2 and C1 like this, yeah, or C3. I don't know. Maybe 3 by 3 matrix. You have to prepare, yeah. Prepare if it is 3 by 3. Yeah. Remember, when you are facing a determinant problem and then you have to find out the lambda, you don't have to force the determinant into quadratic equation, cubic equation, and then find the roots. Okay. No, you see, I don't expand the roots like using the ABC formula in this case. Yeah. Use your logic.
It's okay to use.
Yes, it is okay. That's
Correctly,
okay. Yes. Yes.
Legal.
That's
Bisa kayak
legal.
gini, kan di plus minus 1 sama dengan ini aja. Polinomial aja sih.
Okay, now in the final form, after you find out the C1 and C2, then xt will be half times this plus this is minus half, yeah. 1 minus 1. Okay. Now as time goes to infinity, let's say when t goes to infinity, what it will become? Half.
Apa sih? Itu dekat nol.
Hah?
Half.
Half, then multiply by what? The factor 1, 1. What about this? Going to be 0. So this will be the steady state value.
Do we need to write that?
No, only if you are asked. So this is the final behavior. It can also be stated as steady state value or steady state behavior, final behavior, okay. Interchangeable meaning. Okay, no one is listening, I think. Are you listening to me?
If we are asked to find it.
If we ask the steady.
Yeah, you find out. Yeah, you force t goes to infinity. Then what happened with the equation? You just write that down. Okay. Yeah, he didn't listen. He went out.
Steady state.
Okay, so we end the class here. Before the exam in next Tuesday, you can still ask me at IoT Lab. Yeah, on Monday, let's say, if you have time, you can come. You can ask. It's okay if you don't come. You can come. I said you can come. You said for what? Yeah, if you have question.